Good morning, dear students. My name is Ferhan Mazher, and today is 9th February 2022. Right now, I am with the 9th Cambridge class, and the subject we are studying is D Maths 4024. And today we have set our hearts to solve an exercise 11B from the book D3. The name of the book is New Syllabus Mathematics 7th edition D3, and we are working on its chapter number 11, and that chapter is about the congruency and the similarity of the triangles. We are working on the exercise 11B. In this video, in this session, we will be working on question number 9, 10, 11, and 12. So let's start today's lesson. So, my dear students, D3 and chapter number 11, exercise 11B, question number 9 is showing up on your screen. In the diagram, the ABC and the BDC angle, they both are equals to 90 degree. So they are talking about this angle and this angle. And AD is equals to 3 meter. AD, this is 3 meter, and the BD is also it's 4 meter. So identify three similar triangles and prove that they are similar. So here in this you can see there are three triangles: this full triangle ABC, this triangle ABD, and this triangle CDB. So these are the three triangles, and we have to prove that they are similar to each other. The proof is very simple. You see, if this is 90 degree, this angle here will be also 90. So I will take this triangle BDC and I will prove that this is similar to the ABC. And in the same way, I will take this triangle whose name is ABD and I will show that it's similar to the ABC. So the methodology is very simple. This angle is 90. This angle if I take this angle, so this angle will be common in the BDC triangle and the ABC triangle. So I will prove that the two angles are same. So then the triangles will be similar. You know, that is angle similarity test. And so let's start, and here we go. So on your screen you can see, first of all, I'm going to talk about the big one and this triangle, this big triangle ABC and the BDC triangle. So in these two triangles, you can see that the angle ABC, this angle is 90. In this triangle, the angle BDC, they both are 90, and it is given in the question. The angle BCA and the angle DCA, they both are equal to each other because this is common angle. So I can say, because you are comparing two triangles and the two angles are same, so these two triangles are similar to each other. So the triangle ABC is similar to the triangle BDC. The reason is angle. So we are talking about the ABC and the triangle BDC. So they are similar to each other with the help of the angle similarity test. Now I will take this triangle, this one and the big one, the full one. So this angle will be common and these two angles will be 90. Okay, so in these two triangles, the ADB and the ABC angle, they both are 90 degree. Then the BAD, BAD and the CAB in the big triangle, that angle is common. So I can say that the triangle ADB is similar to the triangle ABC. The reason is angle similarity test. So this is how you will prove that these two are similar. These are the three triangles which are similar to each other. Okay, now he says find the length of the BC. He wants us to find out the length of the BC, and he wants you to find out the length of the CD. BC and the CD. Okay, so let me show you how this is done. So AD by AB, so we basically, the BC is the question, the BC side is the question. So if you want to find out the BC, so let's talk about this triangle. I'm talking about these two triangles similar to each other. So by the name, you can write the ratio of the sides. For example, from here, if I take AB ratio BD, so AB ratio BD. So basically, they have taken these two triangles. So from these two triangles, I can write AD by AB. You can see here AD by AB. In the same way, I can say DB by BC. DB by BC. In the same way, I can, from this name, I can say AB by AC. AB by AC. And if you look at the diagram, the AD is 3, the AB is 5, the the the, the DB is 4, and the BC is question. So cross multiply, so you will have the BC equals to 5 multiply 4, that will be 20, 20 divided by 3, and that will be 6 whole 2 by 3. So hope you understand how. The next question is find the CD. CD, so first I will take these two, they are similar to each other. So AB by BD, here you see AB by BD, and BC by DC. You can see here, I've written here, sorry, the small one was here, AC by BC, AC by BC, and BC by DC, BC by DC. So I will put their values 5, 4, and I know the value of the AC of the BC now. I have taken these two and I made it them equal to each other. So the BC will be 6 whole 2 by 3, and the DC is the question. So cross multiply here. So you will have the DC equals to, you know, 20 by 3 multiply 4 by 5. So you will have 16 by 3, and that will be 5 whole 1 by 3. So this is how you will solve question number 9, and its second part. Hopefully understand. It's a lot of technicality in it. Okay, so now let's go to the next question. We are done with now we are on the question number 10. So let's reduce the size a little bit. Okay. Question number 10 is showing up on your screen. He says the diagram, in the diagram, PQ, RS, and TU. PQ, RS, and TU are parallel lines. The QS 8 centimeter, SU 4 centimeter, QR 12 centimeter, and RU is 6 centimeter. Their question is find the length of the RT. They want you to find out this length RT and the PR. Then they want you to find out the length of the PR. Okay, so that's the A part. If you look at this diagram, this small triangle and this big triangle, QRS and the QTU, they will be similar to each other. So the ratios, I can take the ratio. The small triangle, this side is 12. The big triangle, this side is 12 plus RT. And that's the question, will be equals to this side of the small triangle, that's 8, divided by this side of the big triangle, that will be 12. So let me show you. This is how you find RT. Okay, so now RT, so you will have 12 divided by 12 plus RT equals to 8 divided by 8 plus 4. So this cross multiply. So 8 bracket 12 plus RT bracket close equals to 12 into 12. So 96 plus 8 RT equals to 144. So the 8 RT will be 144 minus 96, and that will be 48. So the RT will be 48 divided by 8, and that will be 6. So the RT value will be 6. The RT value will be 6. Hopefully you understand. Now, the next part, the next question is find PR. Now I will take this triangle. You see, this big triangle and this small triangle. They are similar. So here, the small triangle, this side is 6 divided by the PR plus 6. This big side is PR plus 6 equals to 4 divided by 8 plus 4, 12. So we are talking about the RSU triangle and the PQU triangle. So they are similar to each other. So I can take the ratio of their sides and I can find the PR. Hopefully you understand. Let me show you how this is written. Now the PR is the question. So 6 divided by 6 plus PR equals to 4 divided by 12. So cross multiply. So 6 bracket 6 plus PR equals to 6 into 12. So 6 plus PR is equals to 6 into 12 divided by 4. So 6 plus PR will be equals to 18. So PR will be equals to 18 minus 6. So PR is equals to 12. So this is how you find the PR, that's 12. So the value of the RT is 6 and the value of the PR is 12. Now, they want you to find out the calculate the ratio of the PQ and the TU. PQ and the TU. Okay, so look at this bow. This bow. Can you see this bow? Can you see this bow? We are talking the PRQ and the TRU. Okay. So I will take the ratio because these sides are parallel to each other. So these two triangles of this bow, they will be similar to each other. So if this side will have the ratio with this side, so the this is 6, this is 12. So same will be the ratio with the TU and the PQ. Okay. So first they have written this one. So this is 12. So I can say 12 by 12 ratio 6 will be equals to the PQ ratio TU. So the PQ ratio TU will be 12 ratio 6 and PQ ratio TU will be 2 ratio 1. We cancel it with the 6. So this is how you do the question number 10. Okay. Question number 11 is coming up on your screen. He says RAT is a right angled triangle. RAT. Right angle triangle with the ART angle equals to 90. This angle is 90. The RA equals to 6 centimeter. This side is 6 centimeter and the RT, this side is 8 centimeter. If the triangle is folded along the line MN, vertex A coincides with the vertex T. So when this T will be coincided here, so this will be prove that the MN is perpendicular to the AD. So you see when you will fold this triangle along the MN and the T will coincide with the A, so the AN will be equals to the NT. This angle will be automatically of the 90 degree. Let me show you my written answer. So since A coincides with T when the triangle is folded, A and T is a straight line, hence the MN is perpendicular to the AT. Hence the MN is perpendicular to the AD. So that's the first part. Then they question us that name a pair of similar triangles and prove that they are similar. Okay. So I know that this angle is 90, this angle is 90. So I will take this angle. So this angle will be the common angle between the MNT and the ART. Okay. So I can very easily prove because two angles will be same. So I will be able to prove that these two triangles are similar to each other. And then I will be able to find the third part. I will be able to find the value of the MN. Okay. So let me show you. Okay. Now, so I have marked this angle. These angles are 90, 90. So this angle is also 90. So the ART angle and the MNT angle, they both are 90. The ATR angle, this one, ATR, and the MTN, because this angle is common for the small triangle and the big triangle. So I can say that the triangle ART is similar to the triangle MNT. The reason is angle similarity test. So if the two angles are same in the two triangles, then those triangles are similar to each other. Now the question is, what is the value of the MN? So from the name, I can write the ratios. For example, AR ratio MN, RT ratio NT, AT ratio MT. So they will be equal to each other. Just put their values. We have the values there. So AR is 6, MN, we don't know that value, so that will remain MN. RT, R to T, that is 8, NT, that I don't know. But you know, because this big one is a right angle triangle, stop for a minute. The big one is a right angle triangle. I know this is 6. I know this is 8, and the AT is the hypotenuse. So I can apply the Pythagoras. Here you can see AT will be equal to 6 square plus 8 square. And that will be the square root of 100, and that will be 10. So the AT is 10. So when you folded it and the T is coinciding with the A, so the AN and the NT, they both will be equal to each other. So each AN will be 5 and T will be 5. So I can take this and I can take this one. Sorry, this one. And AR is 6, MN I want to find out equals to RT, that is 8, and the NT, that will be 5. So cross multiply, so MN is equals to 6 into 5 divided by 8, so that's 30 by 8 equals to 6 whole 6 by 8, that is 3 whole 3 by 4, that is 3.75 centimeter. So hopefully understand you have understood the question number 11. These questions are not straightforward questions. They require prior knowledge and skill. Okay, so that was the question number 11. So we are done with that. Now question number 12, and that's the last part of this exercise 11B. Last question on the exercise 11B. So in the quadrilateral JADE, the AO is equals to JO. So this side is equals to this side. AO, JO, they are equal. EO and the DO, they are equal. So this side and this side is equal. So basically the JD will be equals to the AE. Explain why the triangle AJD, this triangle, and the JAE. We have to prove that these two triangles are congruent. Very simple, straightforward question. Okay, now the OJ and the OA, they both are equal. It is given. OE and the OD, they are equal. It is also given. JOE angle and the AOD angle, they are equal, because this angle and this angle, they will be equal because they are vertically opposite to each other. So that means that the JOE triangle and the AOD triangle, they are congruent to each other. That is side angle side postulate. Now, because these two triangles are congruent, so these sides are corresponding sides, so they will be also equals to each other. So it means JE equals to AD, corresponding sides of the congruent triangle. So the JA and the AD, they both are equal to each other. So now I can take this triangle. I can show you AE, and the JD, they are equal. It is given. AJ and the JA, they both are equal because this side is common to both the triangles, which we are trying to prove congruent to each other. So the JE and the AD, they both are equal because they are the corresponding sides of two similar, two congruent triangles. We have proven it in the last part. So I can say that the AJE triangle and the JAD triangle, they are congruent to each other. The reason is side, side, side postulate. So, my dear students, we are done with the exercise. Today in this video, we have reached the end of the exercise 11B from the D3, and I have tried my best to explain to you the basic concepts. Okay, so let me show you the camera. I have switched on the camera. Okay, so my dear students, today we have completed the exercise 11B, and we have tried our best to explain you to the concepts of the 11B. You see, the 11B requires a lot of practice for writing and recognizing the similar triangles, and then using the similar triangles to find the unknown sides and unknown angles. It is very, very important, and I can tell you that the most difficulty the students of 11 Cambridge are facing is to write these arguments in which you prove that the two triangles are similar to each other or they are congruent to each other. So pay attention to this chapter and repeat these questions, do the examples, do the practice now questions. Hopefully you will get the command over these concepts. So once again, thank you very much, everybody. It is a great pleasure for me to teach you online. And don't forget to subscribe my channel, share the link of this video with your friends through your Facebook accounts and through your Twitter and your Instagram accounts. So keep watching my videos, keep sharing my videos. Thank you very much, everyone. Have a good day. God bless you all.